Welcome to part 7 of the Module 9 exam review, the last piece. So we're going to do some absolute value inequalities and some graphing systems, and we're done. So the first one we're looking at is 3x minus 2 is greater than or equal to 5. Now, when we have the absolute values greater than or equal to, this turns into an OR problem. And just like with the equations, we have positive and negative solutions. So the positive case is when our 3x minus 2 is greater than or equal to 5. Everything's positive, we leave alone. The negative one, we have a 3x minus 2 is less than or equal to negative 5. So we make the number negative when we flip the sign. So because we're looking for an OR, we're looking for anywhere where the graph is colored. Solve these individually, so add 2. We get 3x is greater than or equal to 7. Divide by 3, divide by 3. X is greater than or equal to 7 thirds. So here we have 7 thirds. X is greater than or equal to that, and we're good with that. Now, here we add 2. So we have 3x is less than or equal to negative 3, divide by 3. X is less than or equal to negative 1. Negative 1's right there. Less than or equal to is over there. So we can say a couple things. We could use this and that and use OR. So x is greater than or equal to 7 thirds, or x is less than or equal to negative 1. Or we can use the interval notation, negative infinity to negative 1, including negative 1, union 7 thirds to infinity. Either one of those is good. Okay, so looking at the second one, we have absolute value of r plus 7.7 is less than 6. Now, because we have less than, this is an AND problem. So we're going to be looking for anywhere there's overlap. So if the absolute value is less than or equal to, we're looking for that. So we have both cases again, the positive case, r plus 7.7 is less than 6, and the negative one, where we have r plus 7.7 is greater than negative 6. Here, subtract 7.7. So we have r is less than negative 1.7. So negative 1.7, less than that, we're down here. Okay, here when we subtract 7.7, we have r is greater than negative 13, r is greater than negative 13.7. So let's say that right here, this is negative 13.7. We're greater than that. So where does it overlap? Well, between negative 13.7 and negative 1.7, that's everything in between. We're not including those, so we can say negative 13.7 to negative 1.7, not including those, or negative 13.7 is less than x, which is less than negative 1.7. Either one of those is good, and we're looking for the overlap. So in this next one, we got 8. Absolute value of x plus 1 is greater than or equal to 2. First, we want to solve for the absolute value, so divide both sides by 8. So we have the absolute value of x plus 1 is greater than or equal to 1/4. Because we have the absolute value is greater than or equal to, this is an OR problem. So we're looking for anywhere the graph is colored. Positive case, x plus 1 is greater than or equal to 1/4. Negative case, x plus 1 is less than or equal to negative 1/4. So we made the number negative, and we flip the sign. So here, subtracting 1, these cancel, we get x is greater than or equal to. Now, this 1, we could say that's 4/4, so this x is greater than negative 3/4. So negative 3/4, x is greater than that. Here we subtract 1. Subtract 1, which we can say is 4/4 again. We get cancellation. X is less than or equal to negative 5/4. So this right here, negative 5/4, less than or equal. We're down there. So right here we could put that inequality and that inequality as long as we put and in between. Or we could write this as the two distinct disjoint intervals, negative infinity to negative 5/4. Now square in bracket, because we're including it, union, we're including negative 3/4 to infinity. Now we're including those in square brackets because we have less than or equal to and greater than or equal to on those ones. So next one we got is the absolute value of 5 minus 2x over 7 is less than or equal to 3. So once again, the absolute value is less than or equal to the number, so this is an and problem. We have our positive case, 5 minus 2x over 7 is less than or equal to 3. The negative case, 5 minus 2x over 7 is greater than or equal to negative 3. So here, multiply by the 7 to get rid of the 7. So we get 5 minus 2x is less than or equal to 21. Subtract 5. Negative 2x is less than or equal to 16. Divide by negative 2. Now we're dividing by negative 2. So because we're dividing by negative 2, we want to flip the sign, say x is greater than or equal to negative 8. Here, multiply both sides by 7. So we get 5 minus 2x over nothing, because the 7 is canceled, is greater than or equal to negative 21. Now we need to get rid of the 5, so subtract the 5. Negative 2x is greater than or equal to negative 26. Divide by negative 2. We're dividing by a negative, so we flip the sign, and we get x is less than or equal to 13. So here, this is an and problem, so that's a perfectly valid solution. If we want to graph this, x is greater than or equal to negative 8, so that's negative 8, we're going this way. X is less than or equal to 13, that's 13, and we're going this way. So we could write the interval, negative 8 to 13, including both those, and that's where the overlap would be. So that's what we're doing on that one. So just kind of summing this up again, a couple things. If we absolute value less than or equal to number, this is always an and. If we absolute value is greater than or equal to number, this is always an or. And those are generalizable principles. That's how we determine whether we have an and or with these absolute value inequalities. And there's always the two cases. There's the positive case and the negative case. The positive case and the negative case. So keep those in mind when you're doing those problems. So the last couple are graphing systems of inequalities and finding the vertices. We have 2x plus y is less than or equal to 4. And we have x minus 1 is greater than or equal to 0. So first thing we're going to do is graph this. First thing I'm going to do is graph this first one. Because we have less than or equal to, I want a solid line. So I'm graphing 2x plus y equals 4. X and y, if I put 0 in for x, 2 times 0 plus y equals 4. So 0, 4. 0, 4, that's that point here. If I put 0 in for y, I get 2x plus 0 equals 4. Divide by 2. X equals 2. So we have 2, 0. That's the line. Now we need to pick a test point and plug it back in to see which way we're going to shade. I'm going to pick the origin 0, 0. So 2 times 0 plus 0, is that less than or equal to 4? Well, is 0 less than or equal to 4? Yes. So we're shading this way. Now let's look at this one. Because we have greater than or equal to, solid line. So we have x minus 1 equals 0. If we add 1, we get x equals 1. It's a vertical line that goes through 1. Now, because we want x greater than that, we can plug this in. Is 0 minus 1 greater than or equal to 0? No, it's not. So we're shading on this side. So this little piece right here, that is our solution set. And we need to determine what this point is. Well, we know right there x equals 1. So by plugging that into this equation right here, 2 times 1 plus y equals 4. Subtract 2, we get y equals 2. So this is the ordered pair 1, 2. That's the vertex. And this piece right there, that is the solution set that we're looking for. So once again, with these systems of inequalities in two variables, our solution sets are graphs, not so much numbers and numerical things. And the vertices is just the points where the lines that are adjacent to our solution sections touch. So the last one we have is this. X plus 2y is less than or equal to 10. Then we have 2x plus y is less than or equal to 8. Then we have x is greater than or equal to 0, and y is greater than or equal to 0. So, if we have y is greater than or equal to 0, that means we're not down here and not down here, because that's where y is negative. And really, y equals 0 is a horizontal line that's on the axis right there. If we have x is greater than or equal to 0, we're not over here, because that's where x's are negative, and x equals 0 is the vertical line. So really right here, these are two of our boundaries right there, noting that 0, 0 is one of our solution sets. That is, we're shading in this general direction. Now we need to find the graph of that line, which we'll go ahead and do, because we have greater than or equal to, we want a solid line. So we have x plus 2y equals 10. Generally for this, I just put zeros in, so 0 in for that. Just think about it. Now, if like I cover up the x, we have 2y equals 10. So plugging that in, 0 plus 2y equals 10, or y equals 5 by dividing by 2. So 0, 5. That's one of the points. Now, if we put 0 in for y, that's x plus 2 times 0 equals 10. So 10, 0, which is over here. So that right there is what we're looking for, and we know it's going to be underneath this, because if we pick our test point 0, 0, plug it in, 0 plus 2 times 0, is that less than or equal to 10? It is. So we want to be underneath this line, so it's not up there either. Now the last thing we're going to do is graph this line right here, which is 2x plus y equals 8, xy, plug in some zeros, plug 0 in for x, 2 times 0, plus y equals 8, so y equals 8, so that's up here, 0, 8, plug 0 in for y, 2x plus 0 equals 8, so that gives us x equals 4, so we have this point right here, which is 4, 0, draw the line that goes through them. Pick a test point, 0, 0, plug it in here. Is 0 plus 0 less than 8? Yes. So, what that tells us is a couple things. This right here is our solution region. Now, because we found the intercepts, we have 3 of the 4 vertices. In fact, we have the 0, 5, this y-intercept. We have 0, 0, which is both an x and y-intercept. And we have 4, 0, which is the x-intercept. Now, to find this third piece, we're finding where these two lines intersect each other. That is, our line x plus 2y equals 10, and our line 2x plus y equals 8. So we need to solve the system of equations to determine what that third vertex is. I'm going to just eliminate the x's, so multiply by -2, that gives us -2x minus 4y equals -20. Add those up, they cancel here. This is going to give us -3y equals -12, divided by -3. We get y equals 4. So this point right here, something comma 4. To get the x value, plug this in. So we have x plus 2 times -4 equals 10. Excuse me, positive 4, not -4. It's a positive 4. So then we get x plus 8 equals 10. Subtract 8. We get x equals 2. So this is the point 2, 4. So what we have is we have each of the vertices. We have our solution region, which is shaded in there. And that's that. So hopefully that made sense. That's the review. See you for polynomials.